Okay, question 6. A function is defined by f of x is equal to x over root 2x minus 2. We want to state the maximum possible domain of f. Okay, so the domain is the range of values that x is allowed to take. So the values of x that we are allowed to put into the function. So there are problems that are going to arise from this denominator. First up, you can't divide by 0. So 2x minus 2 cannot equal 0. So 2x cannot equal 2, x cannot equal 1. And then the other problem that's going to arise is that 2x minus 2 has to be a non-negative. So it has to be greater than minus 1, but we actually now know it needs to be greater than 0. So 2x minus 2 has to be greater than 0. So 2x has to be greater than 2. So x has to be greater than 1. So the domain of f is x such that x is greater than 1. And I guess we should also say x is an element of the reals. Cool. Okay, then part B says use the quotient rule to show that f dash of x is x minus 2 over 2x minus 2 to the 3 halves. So we're given the quotient rule in the formula booklet. So when you have f of x over g of x, it differentiates to f dashed times g minus f times g dash over g squared. So we usually use a u and a v, which is what we're going to do. So we're going to say that u is x and v is 2x minus 2 to the power of a half. So u is x, u dashed is just 1, v is 2x minus 2 to the power of a half. So v dashed, okay, using the chain rule, 2x minus 2 differentiates to 2. But then when we differentiate the bracket, the half comes down, so that's going to multiply the 2 and just give us 1, and then the power goes down to minus a half. So we get 2x minus 2 to the minus 1 half. Okay, so f dash of x then is going to be, so it's going to be a u dashed times v. So it's going to be 1 times 2x minus 2 to the power of a half minus u times v dash, so minus x times 2x minus 2 to the minus 1/2 all over v squared. So all over, now v squared is just going to be 2x minus 2 to the power of 1. Okay, so we can now do something. Let's multiply the top and the bottom by 2x minus 2 to the power of 1/2. So what that's going to do is turn the 2x minus 2 at the start, 2x minus 2 to the power of 1/2 times 2x minus 2 to the power of 1/2 is going to give us 2x minus 2 to the power of 1, and then 2x minus 2 to the minus half times 2x minus 2 to the half is going to be 2x minus 2 to the power of 0, which is 1. So we get minus x. And then on the bottom, we've got 2x minus 2. Now that was already to the power of 1. So if we multiply it by the same thing to the power of 1/2, we get 3 halves, and then finally the top simplifies to x minus 2 over 2x minus 2 to the 3 halves. Cool. Okay, then part C for 7 marks wants us to show that the graph of y equals f of x has exactly 1 point of inflection. So, at points of inflection, the second derivative is equal to 0. So we need to find the second derivative, set that equal to 0, solve for x. So we know that f dash of x was x minus 2 over 2x minus 2 to the 3 halves. So now we're differentiating this. So again, u is x minus 2, u dashed is 1, v is 2x minus 2 to the 3 halves, and then v dashed. Okay, using the chain rule, 2x minus 2 differentiates to 2. The power of 3 halves comes down, and then we got 2x minus 2, and then the power of 3 halves goes down to 1/2. So 2 times 3 halves is 3. So we got 3 times 2x minus 2 to the power of 1/2. Okay, and then f dash dash is going to be, so it's u dashed times v So that's just going to give us 1 times 2x minus 2 to the 3 halves. And then we get minus u v dashed. So we're going to get minus x minus 2 times 3 lots 2x minus 2 to the 1 half. Now that is all over v squared. So that's all over 2x minus 2 cubed 3 halves, or a power of 3 halves squared is cubed. So over 2x minus 2 cubed. Okay, so remember that at the point of inflection, this stuff is equal to 0. So f double dashed equals 0 means that all of this stuff here is equal to 0. So 2x minus 2 to the 3 halves minus, let's put the 3 out the front, so minus 3 lots of x minus 2 times 2x minus 2 to the power of 1 half over 2x minus 2 cubed is equal to 0. So we can get rid of the denominator, and we're going to be able to get rid of some other stuff too. So we get 2x minus 2 to the 3 halves minus, let's let that 3 into the x minus 2, so we got minus 3x minus 6 times 2x minus 2 to the power of 1 half is equal to 0. Now we have a common factor of 2x minus 2 to the power of 1 half. So it might be tempting at this point to divide that common factor away, but if we do that, we lose a solution. So instead, we factor it out. So we're going to say then we got 2x minus 2 to the power of a half times, now if we divide 2x minus 2 to the 3 halves by 2x minus 2 to the 1 half, we just get left with 2x minus 2 to the power of 1. And then we're going to have minus 3x add 6 is equal to 0. So now we got 2x minus 2 to the power of a half times, so we got 2x minus 3x, so that's going to give us a minus x, and we got a minus 2 add 6, so that's going to give us 4, so let's write that as 4 minus x. Now that stuff is equal to 0, so either 2x minus 2 is equal to 0, which would tell us x is equal to 1, or 4 minus x is equal to 0, which would tell us x is equal to 4. Now it told us to show that there is only one point of inflection. We've got two solutions, but remember what we did in part A? We found the domain of the function x had to be greater than 1. So this is an invalid solution. Okay, so we potentially have this point of inflection when x is equal to 4. What we now need to do is check that it is a point of inflection by seeing what the gradient is doing on either side of x equals 4. So let's take this to where we have a little bit more room. So our second derivative is equal to 2x minus 2 to the 3 halves minus, let's try and clear this up a little bit, so we can say 3x minus 6 times 2x minus 2 to the half all over 2x minus 2 cubed. Okay, so let's see what the gradient is doing to the left. So let's go when x equals 3, f dash dash of 3. Okay, we're going to get 2 times 3 minus 2, so 4 to the 3 halves minus 3 times 3 minus 6, which is 9. No, it's not. 3 times 3 is 9, minus 6 is 3 times 4 to the 1 half all over 4 cubed. Now that's going to give us 4 to the 3 halves is 8. So we got 8 minus 6, which is going to give us 2 over 4 cubed, which is 64, which is 1 over 32. Now, let's see what happens on the right of x equals 4. So, when x is equal to 5, f dash dash of 5 is going to equal, 2 times 5 minus 2 is 8. So we get 8 to the 3 halves minus 3 times 5 minus 6 is 9. So we get minus 9 times 8 to the 1 half all over 8 cubed. Now, if you put that into your calculator, you will get an answer that is less than 0. So, what's happened is we've gone from a region where the second derivative is positive, so 132, to a point where it's equal to 0, to a point where it's now negative so it's less than 0. And therefore, finally, x equals 4 is a point of inflection and is the only one. Cool. Okay, then for part D, we want to write down the values of x for which the graph of y equals f of x is convex. So, convex happens when the second derivative is greater than 0. Now we know that our domain is such that x has to be greater than 1, and we know our second derivative is greater than 0 everywhere to the left of x equals 4. So it's x is greater than 1 but less than 4. Good times.